we're gonna talk about rock and the rock cycle. So first, what is rock? Rock is a solid aggregate of one or two or more minerals. So geologists group the rocks into three categories. So first, we have the sedimentary rocks. The second one is the igneous rocks. And the third one is the metamorphic rocks. Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks and some shape or form can be found all over the planet. Different types of rock are formed in different ways. There are three main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. These form extrusive igneous rock. Some examples of extrusive igneous rocks are tuff, obsidian, and pumice. Igneous rock make up about 95% of Earth's crust. The next type of rock is the sedimentary rock. Sediment is a small particle of sand and organic material that settle to the bottom of water or land areas, often lakes or ocean. Sedimentary rock are formed accumulate over time into positive step form layers. These layers become squeezed and compressed over time until the next to insulate into a rock. Sedimentary rock are the type of rock in which fossil may be found. For sedimentary rock can be preserved plants and animals remains, whether positive into a sediment layers. Some examples of sedimentary rocks are limestone, shale, and sandstone. The third type of rock is a metamorphic rock. The word metamor means to change form, and metamorphic rock is a rock has been changed by extreme heat and pressure. Sedimentary rocks and igneous rocks or even other metamorphic rock can be changed by heat and pressure into a new kinds of stone or rock. Metamorphic rock can be formed by being dipped under the earth for the pressure and temperature are high, or when rock near the surface heated up by the movement of the tectonic plates or magma. Different types of rock become a different type of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate, sandstone becomes quartzite, and limestone becomes marble. Rocks are slowly but constantly changing. So this is the picture of the rock cycle. So no rock remains the same with time, pressure, and other natural forces to form or to transform. Remember, we can call igneous rock as a primary rocks, and the reason is because they are directly formed from the magma and lava. Within these molten materials is solidified. So anything that is formed from the basic most ingredients of earth has to be done to these primary rocks. Noted that we know igneous rocks called primary rocks. Ultimately, the other rocks, the sedimentary rocks and the metamorphic rocks, are called secondary rocks because they are formed igneous rocks. Let me explain how. You will see igneous rock as the vision of the sedimentary rock and the metamorphic rock exist. Let's see as a story. Imagine the magma coming out to the mantle through organic eruption. Now, this magma cooled stone become a solid crystal, and that is how the igneous rock is formed. Now, as the time passes, there is a weathering agencies. We can also call them extra forces like wind, rain, and other activities. Then slowly breaks down the rocks into the small fragments. That is what we call the sediments. And the small fragments openly done from layers and layers with time pressure, they cement together into sedimentary rocks, as this process called the lithification. So that was the form of sedimentary rocks from igneous rocks. Now, these sedimentary rocks has the tendencies to break apart again into a small sediments. Now comes the part how the metamorphic rock and form. Do you remember those caterpillars changes into butterfly? They call that a process of metamorphosis. So these metamorphoses are occurs in rocks as well, especially when they are heat to 300 to 700 degrees Celsius. Now, the deep where does the heat came from? Now, inside the earth there is amount of heat due to the pressure. Put your hands together, rub them very hard, and due to friction and you will feel heat. Similarly, when earth tectonic plate move their own, it produces heat. The plates converges, comes closer, deep in mountains due to the amount of pressure and heat. Now that we know the heat comes from, what does this heat do to the rock? It bakes them, just like how you bake a cookie. It does not melt though, right? It changes its forms. Similarly, rock do not melt too. It transforms into metamorphic rocks. That's why you find metamorphic rock mostly in mountain areas. And again, the extraordinary forces from form like rain, water, and these metamorphic rocks can be broken and forms into sediments. And these sediments can again become a sedimentary rock. The rock cycle never stops. The metamorphic rocks and the igneous rock find a way into the mantle through subtractions. It happens when two platen converges, and then one plate moves under another. This way, all the metamorphic and igneous rock find a way into the mantle. And we know mantle consists of molten rock called magma. And again, magma comes out into the surface of volcano through volcanic activity. And that's how we find the sources of activity of the igneous rock. So this is the rock cycle.
Hello guys, my name is Adudin Vivargas. In this video, you are going to learn is all about Earth, rocks, Earth history, mass, extinction. So that's why for our discussion today is all about this Earth history. Volcanic eruption. One volcanic gas, sulfur dioxide, forms small particles called aerosol that also reflects sunlight and cool earth. Carbon dioxide is another gas emitted by volcanoes. It is a greenhouse gas that can cause warming of Earth's atmosphere. Those volcanoes erupt materials capable of causing both atmospheric cooling and warming in many eruptions. The cooling overwhelms the warming effect. This cooling can occur rapidly within a few weeks or months of the eruption. And the second is supercontinent and Earth carbon dioxide budget. Carbon dioxide budget in the modern ocean called polar seawater sinks to the sea floor and flows as a deep ocean current towards the equator. This current transports oxygen to the deep ocean basin and forces the deep water to rise near the equator where it is warm. The current thus makes both heat and gas throughout the ocean and the atmosphere. Ocean currents are partially controlled by the position of the continent. Recall from For example, shale is a clastic sedimentary rock that consists mostly of tiny clay minerals and lesser amount of quartz and organic particle shale, typically split easily along very fine layering. It is usually gray to black due to the presence of partially decayed remains of plants and animals commonly deposited by clay-rich sediment. These organic materials in shale is the source of most oil and natural gas. The formation of oils and gas from these organic materials is the third is organic sedimentary rocks. Organic sedimentary rocks formed by lithification of the remains of plants and animals. Chert is organic sedimentary rock composed of pure silica. There are two types of chert deposits. Number 1, bedded chert occur as sedimentary rocks of layers, and the second is nodular chert is found as irregularly shaped lumps called noodles in other sedimentary rocks. A figure of 3.9 microscopic examination of bedded chert often shows that is made up of the remains of tiny marine organisms whose skeletons are composed of silica rather than calcium carbonate. Bedded chert form as tiny marine organisms that float near the sea surface extract silica from seawater to form their skeleton. When they die, the remains sink to the seafloor to accumulate in layers, eventually forming chert. The fourth is chemical sedimentary rocks. Chemical sedimentary rocks, some common elements in rocks and minerals such as calcium, sodium, potassium, and magnesium, dissolve during chemical weathering and are carried by groundwater and streams to lakes or to the ocean. Streams that carry the salt to the ocean drains most lakes. However, some lakes, such as the Great Salt Lake in Utah, are landlocked. Stream flow into the lake, but no stream exists. As a result, water escapes only by evaporation. When the water evaporates, salt remains behind in the lake. Water steadily becomes salter. Evaporates are rocks that form when evaporation concentrates the salt to the point at which they precipitate form solution. In the fifth is the bioclastic sedimentary rocks. Bioclastic sedimentary rocks is carbonate rocks are primarily made up of the carbonate minerals calcite and dolomite. described in calcite-rich rocks are called limestone, whereas rocks rich in dolomite are referred to as dolomite. Many geologists use the term dolostone for the rock name to distinguish it from the minerals dolomite. Dissolved calcium ions are released into water during the chemical weathering of calcium-bearing rocks. The carbonate union forms when atmospheric carbon dioxide gas dissolves in water. Seawater contains large quantities of both dissolved calcium and carbon dioxide. Clams, oysters, corals, some types of algae, and a variety of other marine organisms contain dissolved calcium and carbonate ions to shell and other hard body parts. When these organisms die, waves in ocean current break the shells into small fragments. A rock formed by lithification of such sediment.
Hello everyone, I'm Rehanasi Panalangin. In this video is talk about geologic time. Geologic history. We're gonna think relative dating of a rock layers. How you learn about Earth history by studying sedimentary rock. To get started, we need to look something. There are two ways of geologic time. The first one is absoluting dating or absoluting age. Absoluting age involves use metanonos radioactive, carbon dating, radioactive decay. Determining actual age of a rock fossil use radioactive decay. For example, the trilobite fossil is 489 million years old, so that is example of absoluting dating. Why? Because using a specific number. Relative dating or relative age determining which rock, fossil, or event came first, second, third, etc. Relative age or dating is not using specific quantity values. For example, the trilobite fossil is older than dinosaur tooth fossil, so the relative age using comparison. Paleontological study. Fossil is understand the history of life and evolution. The oldest known as fossil are traces or bacteria, like organisms that lived about 3.5 billion years ago. As much younger fossil consists of the frozen and the mummified remains of a bronze aged man recently found in a glacier near the Italian-Australian border. Fossils also allow geologists to interpret ancient environment because most organisms thrive in specific environments and do not survive in others. For example, coral lives in clear, warm, shallow seas. Fossil corals are abundant in rocks of many cold mountain environments, such as the Canadian Rockies and the summit of Mount Everest. Absolute age, time measurement in years. Principle of originals horizontally. The principle that sediment is deposited as nearly horizontally, and therefore most sedimentary rocks start out with nearly horizontal layering. Principle of superposition. The principle of that is under stub layers of sediment or sedimentary rock, the age becomes progressively younger from bottom to top. Younger layers always accumulate on top of older layers. Principal cross-cutting relationship. The obvious principle that a rock or picture must first exist before anything can happen to it. Thus, if an interaction of rocks cuts across an existing rock, the dike interaction is younger. Evolution. The biological theory that life forms have changed in their physical and genetic characteristic time. Principle of faunal succession. Ito? The principle that species succeeded one another through time in a definite order, so that sedimentary rocks of the same age contain identical fossil and rocks of different age contain different fossils. Therefore, the relative age of a rocks can be identified from their fossil. Conformable. A conformable, a term describing sedimentary layers that were deposited continuously without detectable interpretation. Unconformity. Unconformity, an interruption is sediment deposit or a break between eroded igneous and overlying sedimentary layers, causing a gap in the geological record for that place. Types of unconformities include disconformity, angular unconformity, and the nonconformity. Disconformity. Disconformity, a type of unconformity in which the sediment layers above and below the unconformity are parallel. Angular unconformity. Angular unconformity in which younger sediment rock rests on the eroded surface of the tidal or folded older rocks. Nonconformity. Nonconformity, a type of unconformity in which layered sedimentary rocks lie on an erosion surface cut into igneous or metamorphic rocks. Correlation. The process of establishment the age relationship of rocks or geologic picture from different locations on Earth can be done by comparing characteristics of the layers or the types of fossils found in the layers. There are two types of correlation. The one is time correlation, age equivalence, and the lithologic correlation, continuity of the rock unit. Index fossil. Index fossil, a fossil that dates the layers where it is found because it came from organism that is abundant preserved in rocks, was widely spread a geography and existed as a species or genus for only a relative short time. Half-life. The time is taken for half of the atoms of radioactive isotope in a sample to decompose. Radiometric dating. Radiometric dating, the process of the measuring that absolute age of rocks, minerals, and fossils by measuring the concentration of any radioactive isotopes and their decay products. Geologic column, a composite column diagram that shows the sequence of rocks a given place or region, arranged to show their position in the geologic time scale. Geologic time scale, a chronological arrangement of geologic time subdivided into ions, eras, periods, and epochs. Ion, the largest unit of geologic time. The most recent ion, the Phanerozoic ion, is further subdivided into eras. Era, a geological time unit. Ions are divided into eras. In turn, eras are subdivided into periods. Periods, a geologic time unit, longer than a epoch and shorter than era. Epochs, the smallest unit of geologic time period, are divided into epochs. Precambrian, a term referring to all geologic time before the Paleozoic era, encompassing approximately the first 4 billions. Hadean Eon, the earliest time in Earth history, racing from 4.6 billion years ago. Archean Aeon, a division of geologic time, 3.8 to 2.5 billion years ago. Proterozoic Aeon, the portion of geological time occurring during a period from 2.5 billion to 543 billion years ago. Phanerozoic Ion, the most recent 543 billion years of geologic time, including the present, represented by rocks that contain evident and abundant fossils. Paleozoic era, the part of Paleozoic time occurring during a period from 543 to 448 million years ago. During this era, interfaith species ambience. Reptiles, sperms, and cone-bearing trees were dominant. Mesozoic era, the part geologic time roughly from 248 to 65 billion years ago. Dinosaurs rose to prominence and became extinct during this era. Cenozoic era, the latest of 4 eras into which geologic time is subdivided 65 million years ago to present.
For watching. I hope you enjoyed the video.
Thank you. I hope you learn more to our videos.
Thank you for watching. Don't forget to like and subscribe.